All right, so now we move on to a two-part lesson. This is lesson 5a, and we'll cover 5b in our next lesson, but 5a is where we're going to begin here. So we want to deal with multiplying a binomial by a binomial, or what we know as two terms and two terms coming together to make a binomial. So there's a couple different strategies for multiplying binomials. The first one is going to be foiling, and this one you should be fairly familiar with. With this one, you would have seen this in previous grades like grade 8 and 9, and that's saying, what if I have two terms in one bracket, two terms in another? How can I expand this? Well, foiling, we start by saying, if I multiply the first, or f, the first terms together, and then I multiply the outer terms together, the inner terms together, and then finally the last terms together, then we should be able to create some form of combined polynomial here when we multiply these, and we should be able to simplify coefficients. Now, here's an example directly applied. Suppose I give you 2x plus 3 and x minus 5, and then I say, I want you to simplify this. Well, first of all, we always want to deal with the FOIL method for method 1, and it's saying we have first, outer, inner, last. If I multiply 2x by the x, or the first terms, I'm going to be given 2x squared. If I multiply my first and my outside, or the outer terms, that's going to give me a 2x times a negative 5, that's negative 10x. Then now if I go to the inner, or the I component, 3 times x will give me positive 3x. And then finally, my last, or the L, 3 times a negative 5 is negative 15. All right. Now, we can go into strategy 2, which is the box method. Suppose I gave you a binomial by a binomial, and my first binomial is 2x plus 4, and my second binomial is 3x plus 6. If that's the case, well, what I can actually do is assign each of those parts of the binomial to one part of the box. And now, how I get my answer on the inside is I take, to get the first box, or the top left, I have to multiply 3x by 2x, which gives me 6x. To get my top right box, I have to multiply 3x times 4, which gives me 12x. To get my bottom left, I have to go 2x times 6 equals 12x. And then finally, to get my bottom right, I have to multiply 6 by 4, which is 24. Now, below they've written that out. They've said, if I know all my boxes here, the 4 boxes, I'm going to add or subtract them based on what their coefficient is. In this case, they are all positive terms. So I'm going to add them all together. And here is my final solution when I add them all together. So let's try one or the other here. So for some of these, I may do the foiling method. Some of them I may do the box method. I'm going to mix it up and show a couple different ways. First of all, let's deal with foiling, because that is our first method. If I foil this, well, I'm actually going to create what I call the Pepsi symbol. I'm going to do my first term, or my first terms, that's the f component. Then I'm going to do my outer terms, which is the 2x times the negative 2. So if I start here, this is equal to 2x times 2y, the coefficients multiply to 2 times 2, which is 4, and I multiply the x and the y together here. Then I go to my outer terms, 2x times a negative 2. That's equal to negative 4x. I then go to my inner terms, or the I, and my last terms, and therefore I'm going to get 3 times 2y is positive 6y, and then 3 times negative 2 is negative 6. Now, I look down the line here and I think, is there anything that can combine here? No, in this case, this is actually fully simplified because I have an xy term, I have an x term, a y term, and then some constant term. None of these can come together, therefore this is my solution here. All right, if I go to this next example here, well, if I deal with the first terms, I'm going to multiply x times x and x times 4. So for my f component, I have x times x, which is x squared. To get my outer, or the O, it's x times 4, which is 4x. Now I need to move on to my inner, which is negative 2 times x, and my last, which is negative 2 times 4. So this will give me negative 2x, and then negative 2 times 4 is I should correct this, this is negative 8, because we have a negative times a positive. And now I realize what can come together. Well, I have two different x terms here. So I'm going to add their coefficients together. X squared, 4 minus 2 is positive 2x minus 8, because the constant won't change and our x squareds won't change, only the ones that had common terms. All right, now what I would like to show is the box method instead. So if I create a box here, I'm just going to create a 4 square box. Whoops, wrong shape there. There we go. And I'm going to cross it. And then now what I want to do is I want to assign each part of the box one part of the binomial. So the first part on the top, I'm going to write x and negative 12, representing my first binomial. Then I'm going to take the 2x and negative 5 and assign them to a spot, 2x and negative 5. You need to make sure whatever the sign in the middle, it follows the number that it's attached to here. So my negative 12 became negative 12 here. My negative 5 became negative 5 here. All right, now we just need to multiply this through. If I want my first box here, I have to take 2x and multiply it to x. That gives me 2x squared. In my next one, I have to take negative 12 times 2x is equal to negative 24x. My next box down here is x times negative 5. That's equal to negative 5x. And then finally, to get my bottom right box here, I need to do negative 5 times a negative 12. A negative times a negative is positive, and then 5 times the 12 will give me equal to 60. All right, now it's about piecing this all together. I'm going to take every term that's in the brackets and write them with their sign, either added or subtracted. This is equal to 2x squared minus 24x minus 5x plus 60. Now, which terms can I combine? I look and I see I have two different x terms here with both x to the 1 degree. So I'm going to combine them together. This is 2x squared. Negative 24 minus 5 is negative 29x. And then finally, plus 60. There is our answer there. All right, I'm going to do the same thing with example D here. I'm going to create the box. So I'm going to do line, line, line. I'm going to split this into 4 sections. Let's hit the back button there. Split that into another section. Awesome. Now I'm going to take one binomial. Let's start with my first one, 2a plus 3. I'm going to write 2a above the first box, plus 3 above the second. I then take my second binomial and I'm going to split it up on the left-hand side here. 2a in front of the first, plus 7 in front of the next. Now, from here, I can go box by box. To get my top left, I multiply 2a times 2a. That's 4a squared. To get my top right box, I need to go 3 times 2a. That's equal to 6a. Then to get my bottom left, I need to multiply 2a and 7. That's equal to 14a. And then finally, 3 times 7 will give me my bottom right box. That's equal to positive 21. Now off to the side, I can say this is all equal to, I'm going to carry those signs and add these all together, add or subtract depending on their coefficient. I have 4a squared plus 6a plus 14a and then plus 21. The only ones I can combine here are the ones with my a here. So my new answer is going to be 4a squared. 6 plus 14 is going to be equal to plus 20a. And then plus 21. There is our solution there. So if we compare these, foiling, box method, two very valid methods to get solutions. However, it's more about what you feel comfortable with. Foiling, I think, is going to be faster for you rather than setting up the box, but the box is a really nice visual and it ensures that you get the correct answer because it's very pictorial, or it's very visual as to what you're multiplying together and then finally what you're adding together out of the boxes. So do whatever you feel best here. I would be familiar with both just so you have some tools to use, but in this case, either one is going to get you the same answer. All right. Now for some special cases. What if I have two binomials that are technically what looks to be the same, but then have different signs under? Well, what we mean by that is, what if they share the same terms, but then the sign between them goes from a negative to a positive, or a positive to a negative? Something really special happens with these. So I'm going to show the foiling method for this example here. If I take my first terms and I multiply them together here, so if I multiply 2a to 2a, and then I take my outer terms and multiply them together, well, first of all, this is going to give me 2a times 2a, which is 4a squared. I then go 2a times 3b is going to be plus 6ab. And then now I need to multiply my inner terms, or the I terms, and my last terms. So this is going to give me negative 3b times 2a is negative 6ab. And then negative 3b times a positive 3b is equal to negative 9b squared. Now, what do we notice here? We have our two terms that we can combine together, 6ab positive and a negative 6ab. That actually cancels out. I can take a red line through these and say they're the plus minus of each other, so this eliminates to 0. Therefore, my answer is 4a squared minus 9b squared. So we're kind of seeing a pattern, but I want to confirm it with one more example. All right, I go to B. B, we're going to do the same thing here. We're going to distribute by doing binomial times binomial multiplication using foiling. I multiply my first term and to the last term here. This is equal to 5x cubed times 5x cubed. That's 25x. I add their exponents to the 6. 5x cubed times a negative 4y. Well, that's negative 20x cubed y. Now I want to multiply my inner terms here and my last terms here. 4y times 5x cubed is positive 20x cubed y. And then lastly, 4y times a negative 4y is negative 16y squared. Which terms do I notice are the same? It's these middle two, and what's nice about them is one's a negative version, one's a positive version, so what I'm going to notice is that these actually eliminate to 0. So my next line is going to be equal to 25x squared minus 16y squared. There's our final answer. So here's the trick. When you see two binomials that are the same but different signs, you know that the middle terms are going to eliminate because you have a plus minus version of them. And it doesn't matter what numbers you give. As long as the binomials are the same but with different signs, the middle will always eliminate. Now, what if we're squaring a binomial? Meaning, what if I have some binomial raised to the power of 2? Well, we know from previous grades, what if I gave you the example where I have something like x times x? Well, this was equal to x squared. So what does it mean to square? Squaring a binomial is saying we're going to write out the same thing twice and then multiply it out. So if I look at my first example here, 2m plus 5n squared, this is equal to essentially 2m plus 5n written out 2 times. And now we've just dealt with this, whether we do the box method or we do the FOIL method, either way, we know how to multiply two binomials together. So I'm going to FOIL this again and say this is equal to 2m times 2m, 2m times 5n. That will start me off with 4m squared. 2m times a 5n is plus 10mn. Now I need to do the inner terms and the last terms. 5n times 2n is plus 10mn. And then 5n times 5n is plus 25n squared. Which ones can I combine? This is going to become a repeated pattern, the middle two terms. So this is equal to 4m squared. 10mn plus 10mn is equal to plus 20mn. And then plus 25n squared. Now, what is this called again? We know if there's 3 different terms involved in the polynomial, or 3 terms that make up the combined statement, this is a trinomial. All right, let's do another example here. So if I take this example here and I say it's squared, that's essentially multiplying this out 2 times by the exact same thing, 7c6 minus 8d3 times 7c6 minus 8d3. If I FOIL this, I start with my first terms and then my outer terms. This is equal to 7 times 7, which is 49, c6 times c6, which is c12, because we add the exponents. Then I go 7c6 times negative 8d3, that's equal to negative 56 c6d3. And then now we need to go to our next terms. We have a negative 8d cubed times the 7. I multiply my last terms. Negative 8d cubed times 7c6. I actually get the exact same term here. 56c6 d7, or d3 I should say. And then finally, negative 8d3 times a negative 8d3 will give me, well, negative 8 times a negative 8 is positive 64. And then I need to add my exponents on the d's. So this is d3 plus 3 is equal to d6. Now, I should notice that my inner terms are going to come together. Because this isn't the plus minus like the previous examples, we have double negative, meaning these are going to come together and add together. This is equal to negative, or in this case, positive 49c12 minus, well, negative 50 minus another 50 is negative 100. And then 6 and 6 come together to make 12. So this is negative 112 c6 d3 plus 64 d6. All right, that is our final answer there. So although the exponents are a little complicated and the numbers are quite large in comparison to some of the other examples, we see that we should get this trinomial again. Or in the case of some of the ones from above here, if we have a plus minus, we know that it's only going to become a binomial because our middle term will eliminate. So if it's plus minus of the same thing, we get a binomial. If we know we're squaring it, whatever that squared term is, most likely we're going to get a trinomial as our result. All right, let's take on the challenge here. We have a binomial times a trinomial. This is going to be the exact same thing that we've been doing before. However, we're going to add one little layer here. Instead of a binomial multiplication being a simple FOIL of 4 things, now it's going to be one more thing on top of that. Here's what I mean. If I multiply this using our FOIL technique, I have to multiply x times x squared, x times 3x, x times 4. And then I have to multiply the negative 5 to each. But I'm going to start by multiplying x to each of the terms in the trinomial. This is equal to x times x squared is x cubed plus 3x squared, or 3x times x. And then negative 4 times x is negative 4x. Now I need to multiply my negative 5 to everything in the trinomial. This is going to give me negative 5 times x squared is negative 5x squared. Negative 5 times 3x is going to be equal to negative 15x. And then finally, negative 5 times a negative 4 will give me a positive 20. All right, here's where the organization comes in handy. Whether you have different colors or shading techniques, we want to say, how many x squareds do I have? How many x terms do I have? How many constant terms do I have? And then finally, I notice that I have some form of straggler term or an x cubed. So we need to combine all the things together here. This is equal to x cubed because there's only the one x cubed here. Now I go down the line and I say, how many x squareds do I have? 3 minus 5, that's negative 2x squared. I then go to my x terms and I say negative 4 and negative 15 come together to make negative 19x. And then finally I look at my constant terms and there's only a plus 20. There is our polynomial. And we know a 4-term polynomial does not have an actual separate term. It's not like a binomial or a trinomial. If it's 4 or greater terms involved in the polynomial, we just call it a polynomial. So this is totally a legitimate answer here. All right, and then we have this final one here. This is going to be quite large because we have a binomial by binomial being multiplied, and then another binomial by binomial being multiplied. Here's what we can do. All this is just an extended problem of the ones you've been doing. This is going to be equal to, I'm going to use foiling, 4m times the 3m, 4m times the negative 2. This is going to be equal to 4m times 3m is 12m squared. We then go 4m times negative 2 is negative 8m. Now I need to multiply my 1 to both of the next two terms in the next binomial. 1 times 3m is plus 3m. 1 times a negative 2 is negative 2. And now we're done with our first binomial and we can move to our second. What I'm going to do is I'm going to keep this positive 2 out front and I'm going to multiply it to whatever the result is from our binomial times binomial. So this 2 that I've written here is strictly the 2 that's from there. And what I'm going to do is now fill in what this binomial expansion is and then distribute the 2. So if I do the binomial by binomial, I'm going to take 2m and multiply it to both the terms. This is going to be 2m times a negative 3m, which is negative 6m squared. I then go 2m times a 4, which is plus 8m. Now I need to multiply my next two, negative 1 to both of them. This is going to be negative 1 times a negative 3, which is plus 3m. And then finally, negative 1 times a positive 4 is negative 4. Okay, from here, I'm going to distribute this 2 out front. I can't do anything until I've distributed this 2 into the brackets here. Now, what I could have done is distributed the 2 right away into the brackets and then did binomial by binomial, but I wanted to show it to you this way. So if I rewrite my statement out, this is equal to 12m squared minus, or I should combine these, I guess. If we're at this point, maybe I'll leave it. Negative 8m plus 3m minus 2. And now I'm going to take that 2 coefficient and multiply it into everything. 2 gets multiplied to the 6, to the 8, to the 3, and to the 4. So this is equal to minus 2 times 6 is 12m squared. 2 times an 8 is plus 16m. 2 times a 3 is plus 6m. And then finally, 2 times a negative 4 is negative 8. Now we can combine all the terms together. I'm going to go down the line and highlight or underline them with different colors. My m squareds are going to get yellow, so I'm going to highlight all these, including the coefficient. I'm going to go through and highlight all of my m terms, which because I didn't add them together earlier, I now have 4 of them. And finally, I'm going to highlight my constant terms here. So this is going to be equal to the 12m minus the 12m is 0m squared. We have negative 8m plus 3m, which is negative 5. Plus a 16 will give me positive 11. And then 11 plus a 6 will give me plus 17m's. And then finally, I look at my constant terms, or the ones with no variables, and it's negative 2 minus 8. That's negative 10. So my final answer is therefore 17m plus 10. I get a binomial from this expansion of a binomial times a binomial plus a binomial times a binomial. All right, this is where you get to check your understanding.